Well, thank you so much for coming. Okay, I think I don't have to convince you why bees are important, but I'll start with telling you why they're important. So they pollinate about 85% of flowering plants. So this means that in a natural ecosystem, these guys are what we call keystone species. So they have a kind of a disproportionate importance in an ecosystem because if you get rid of them, it causes lots of things downstream from there that you have to worry about. They also are really important economically because they pollinate a lot of crops. And if you think of Iowa, you can think maybe they're not that important because, you know, corn is wind pollinated, they don't need them. And soybean is, they actually could use bees. They do increase yield, but they self-pollinate a lot, so they don't really need them. But the thing is that they pollinate a lot of things that give us the richness of what we eat. And people have studied also that certain nutrients are not in those foods like you know, corn and wheat. And if we only ate that, we would be lacking certain vitamins and folic acid, you know, certain nutrients that are only going to be available through, or mostly available through plants that are pollinated by bees. So we need them. This is what it looks like with and without bees. So this is just a strawberry and a raspberry where they experimentally like just put a little like net on top of the flower before it is ready to be pollinated, and so they can't access it. And this is the result. Delicious. So that's what we gotta, you know, like this is why it's so important to conserve these guys, so we can have, you know, juicy fruit at our disposal. To give you an idea of like how productive these guys are, this is kind of extreme, like a super hard worker lady here. The blueberry bee, this guy can visit up to 50,000 flowers. One individual can visit about that. And that they've estimated results in the production of about 6,000 ripe blueberries, which in cost, market cost is about $20. So one bee has that cost. Not that every single bee has that much of a you know, monetary value. This guy is an extremely hard worker, but just to give you an idea that it's not only important to conserve because of the, you know, conservation of natural environments, but for economic reasons too. You gotta convince some people with that argument. Everybody thinks of the honeybee when you think of honeys. That's actually not my specialty. I study all the other ones, the native bees. And people think in general that there's one species then, but really worldwide we have 20,000 species. In the U.S., about 4,000, and in Iowa, 400. We got a good number here. And they all are approximately, you can see, because there's tons of species that still need to be described. So scientists have estimated that this is actually a significant number, that it could go up a decent amount. And just to give you an idea of the size range, these two guys are not a honeybee, and they are carpenter bees, two different kinds. The big guy, you probably have seen it because or you definitely noticed it. It looks like a bumblebee, but its abdomen, its little butt, is shiny, so it doesn't have hair. And you probably see them because they're carpenters, so they make their nests by making their own holes in wood. And lots of times you find them in your decks. When you're like hanging out outside and you hear a buzzing, it could be one of those guys if it's not the flowers. And its little sister over here, tiny one, like 5 millimeters. It does the same thing, but, you know, like less hard wood. They usually dig in the middle of little twigs. They have like the softer material in the middle. But just to show you how the gigantic range of sizes we have. And I brought some bees for you guys to see here. So at the end you can come look at them. I definitely brought these two specifically so you can see the actual size of them in real life, and there when they're not buzzing, they're just walking around. Bah, they're not walking around, they're pinned. Okay, so before we get into the bee stuff, I wanna see if you actually know how to find a bee. So here, tell me, think about this. How many bees do you see here? Okay, who says 1? Who says 2? Who says 3? 4? I didn't see you guys vote. She voted. Actually, it's 2. And so if you said one, you're probably thinking of this one because that looks, like the fuzziness that we're used to seeing. But this guy is also a bee. And I'll show you later why it looks like that. It looks like a wasp. And these guys are just wasps. Now here, how many bees do you see here? Okay, one?
None.
Okay, none, that's an option. And no, anybody think that there's no bees here?
Maybe one.
2 people? 1, 2, 3, everyone's confused, 3, okay, 4, 5, all of them? Who says all of them?
0.
It's none of them.
Yeah.
So this is a mix of flies, so these guys are all flies. And these guys are all, anybody know? Moths. So they're all mimicking bees. So a wasp look like bees because they're closely related. But these guys are very distantly related, and they just mimic them. It's an evolutionary strategy because these guys don't do anything, so they would be eaten a lot faster if they didn't, look like they could sting a bird or whatever was trying to eat them. So when you start looking at them more specifically, you really can tell the difference right away. Something that my students learn at the beginning, they're like giving a lot of flies, and then they realize right away, no. So this one thing that you can use to tell them apart is that the eyes are enormous in a fly. They occupy most of their face. And then their antenna, you see there's like nothing going on, like a little thing. They have a weird like little bulb thing with a tiny thing coming out of it. And a bee has regular antenna, and their eyes are like just on the side of their face. And then these guys just look like butterflies. Their mouth parts have like that, and the thing that makes them look most is that they've lost the scales. So the most butterflies and moths have scales that give them that color, and here they've lost a few to make them look like they have see-through wings now. Okay, but now that we know what a bee is, let me tell you a bunch of cool stuff about them. Hopefully, I'll be able to blow your mind. I think this one is one of the coolest things, one that comes. Bees can choose the progeny of the sex of their progeny. So they can decide if they're gonna lay an egg that will be a female or will be a male. Super important task. And the way that they do this, pretty cool too, is that most, like us, we're what we call diploid. And a lot of organisms are like this. And this is because our chromosomes come in pairs. So we have 46 chromosomes, but we have 23 pairs. One of each pair came from your mom and one from your dad. So then the gametes, when we make sperm and eggs, they're gonna have only one of each of the set. And then they come together and form the whole individual. Bees, to make females, do this. So they have an egg, they fertilize it with sperm, they have a diploid individual, and those are females. So with 2 chromosomes for every, so 2 of each set, yes. But then when one lay a male, they just don't fertilize the egg. So a male is actually an unfertilized egg that develops into a male. And you say, how do they choose if they fertilize it or not? So they work a lot different than us. Because insects in general, the sperm isn't transferred like a liquid. It comes in a little pack. It's called a spermatophore. And and then the female has a little place in their genitalia internally that it has to store it, the spermatheca. So when a female comes out to mate, usually this is just early in the season, in the case of the honeybee, when they swarm. But in general, the other bees, just at the beginning of the season, when they emerge, they come out, they mate usually with more than one male, and so they store all the sperm, and that's the sperm that's going to last them forever. So for the honeybee, for example, that colonies last for years, that it's the sperm that she got, that one nuptial flight is called, where she gets to get some action, and that's what has her like thinking forever about the good times. Like just that one event, that one nuptial flight is the sperm that's going to last for up to 5 years. A colony can last. And actually, that's what it can cause the decline of the colony is that when she runs out of sperm, then she just lays eggs that are unfertilized, and so those are males. Males don't do anything, so that means the colony starts to decline because there's nobody there to do the work. Cool or no? The sting. So we always think about that. Most people think of bees stinging. Only females sting. Did you know that? And that's because the sting is actually a modified ovipositor. So the thing that they use to lay the eggs, they used to. Now it's so modified into a sting that it's too skinny for an egg to go through there. So they actually lay their eggs from the base of that. But because it's the ovipositor, then only females have it, so only females can sting. And then the other thing is that you always hear about this happening, that the honeybee, when it stings you, it dies. The honeybee is the only one that does that. So the honeybee is very atypical compared to all the other 20,000 bees in lots of ways. And this is one of them. Their sting is barbed. And so that's why when it goes in, then it can't come out and it ends up leaving with all its intestine. But most bees don't have that barbed thing, so they can just sting you a million times. But they're not aggressive. The honeybee is more, I get stung a lot. If you're actually like manipulating them, they do sting you, but it's like, it just hurts a lot and then nothing, you don't see anything. But if you're not doing anything to them, they're not going to be aggressive because they're not protecting their colony. I'll explain later that. The other thing, most bees are single moms. We think always of the honeybee. The honeybee is social, but only like less than 10% of bees are social. Most bees are solitary. And so that means that each girl is working for themselves. Only females work, and they have to build their own nest. And in that nest, it's usually, most of them are in the ground, so they dig a little hole, and then at the end of that hole, and that depth varies widely, but they make a little cell there that they line on the inside, and that's what they provision with the food that all baby bees eat, all the larvae, which is the bee bread. You may have heard this from beekeeping too, if you are into that. It's just a mix of pollen and nectar. That's their food. And so they make a little ball of that, and so that's why they're working so hard going to get pollen and nectar. They make a little ball, lay an egg, and then seal that cell, and then do that over and over again. So they have a bunch of individual cells there that are going to give her progeny. Bumblebees are actually in North America the other social bee. There are multiple species, but they're the only ones. So honeybees, which are introduced, and then the native bumblebees are the only social things that we have in North America. And what's cool about these is that the bumblebees have to incubate their eggs. Not always, the first batch only. Because their nest, even though they're social too, they're eusocial. They're called like very developed social behavior. So it's like one female is only fertile, and then they have division of labor with the other ones. But they're annual, so they're not like the honeybee that can last for many years. These guys are just for one season. So now, in this moment, queens that are going to be the queens of the hives next year are just mated, or they're mating right now. Today's a good day, so probably lots of things going on. And then they have to go find a place to hide for the winter. And then when it's getting nice out, they come out. This is the ground. They come out, and they already mated, so they're ready for that. So now they just have to find a suitable place to nest, so on the ground. And then they make these like honey pot things, and that's what they fill with the bee bread, and lay their eggs there. But this is the queen doing everything by herself at this point. And so she collected, all the food that they need, and she wants to speed it up. So she same as a chicken. They put them on their belly and incubate them. She fills one of these up close to it with nectar, so she doesn't have to do anything. She's like just eating and incubating until those guys, hatch and turn into adults, and once you have your first batch of adults, then she can lay back and just lay eggs, stay in the nest, and just focus on reproduction, while all the other ones go out and do the work, like a honeybee. But then at the end of the season, she's going to lay eggs that are going to be queens, and she dies, and that was all she did. That was her work. Another thing that might be surprising is that most bees do not produce honey. And I showed you here the other ones that do honey, that make honey. So the honeybee is, from Europe, and there's a few other species and subspecies that are very similar to the honeybee. There's an Asian honeybee, and you've heard of the African honeybee, that's a killer bee. Those guys work in the same way as the one that we're used to here. But this other whole group that's hundreds of species have you heard of the stingless bees? So these guys are from the tropics, and they are similar to the bee in lots of ways. So they're very closely related, and they have hives that are perennial too, so that don't die every year. They last for multiple years, and actually these guys can last for a lot longer. Because they've documented up to 80 years, one colony in one place. And they produce honey. It's really different, though. Anybody here had honey from a stingless bee before? Me neither. But the biology of it, like just from that you can tell that it's going to be different because these guys are in the tropics, so they don't have to do the same things as the honeybee. The honeybee condenses their honey, so they collect the nectar, and the nectar has lots of water in it, and they want to reduce that water content. And so they do different things. So they go in and bat their wings so that they evaporate the water, or they do a thing called bubbling, where they have the nectar in their a crop that is called, and they kind of bring it out and in, like playing with their fruit, kind of out, in and out, and that does the same effect of evaporating the water. And because they do all that stuff, the honey then is good to last for, well, they can store more of it to begin with, and then it won't ferment because it's so dense that things won't grow on it, so concentrated that things won't grow on it. And so they can last for the whole season, and that's why we can also keep it for a long time ourselves when we buy honey. These guys, since they don't have a harsh winter, they always have flowers available to them. So they're not worried about storing for a winter where they're not going to have access to floral resources. So they just don't bother in condensing it that much. They also don't make a lot. They make way less than the honeybee, and they make it in these things, these little honey pot things, and you can see from this that it's not as easy to harvest either. So the way that they have figured out how to, how we make the honeybee use the frames and stuff, that is really convenient. People have figured out a really easy way to extract it and get a lot of honey with not that much effort. These guys, it's not that easy. I love these guys. I brought some of those for you guys to see too, so you can compare it to the honeybee. And I love them because, in addition to having super cool biology, they also have a cultural significance. So these are from the tropics, so they're everywhere. They're in the neotropics in Latin America. They're in Africa. They're in some Asian, part of the tropical part of Asia, and Australia. But lots of cultures have actually been doing apiculture with these guys. Meliponini is the tribe of these guys, so that's why they call it meliponiculture. But they have, it has been documented that the Mayas actually did this for hundreds of years. Well, they have, they used to have before Spaniards destroyed all their written things, but there's still some evidence left in some archaeological sites. So in the peninsula of the Yucatan, there is one of the archaeological sites, Tulum. Has anybody been there by any chance? Because there's also beautiful beaches. It's also cool place. This is from the Yucatan. They have, in that archaeological site, there are, they have lots of gods sculpted onto that thing, and one of their gods is a stingless bee. I really love that it's not like a typical view like this of a bee, or what you see when like a T-shirt or something. It's the face of the bee, and that to me makes me think that it's like a very intimate relationship that they had with them. And this is actually why we know that that they lasted so long, because that a hive can last for so long, because these Mayan communities, they would have them. Everybody would have them at some point, and they would just be passed down from generation to generation. The same hive. So they would go out and just these guys make nests in pre-existing cavities. Usually in trees that have holes, that's what they choose. So they would go find these and just cut the whole trunk. So you can see this is just a trunk that they got from when they found it. They cut it down and they brought it in. And that's how they're going to harvest from where they're going to harvest. Not a very easy thing. So they're not going to get, like a gigantic bear, like little bear jars of honey. Actually live very small quantities. And the Mayans used to use them traditionally more for medicinal reasons than for the sugary part of it. They definitely have, it's already been proven, they have antibacterial properties. And that makes sense if you think of it, because I told you that they don't evaporate the water from it, so it's pretty liquidy. And so that means that makes it likely that they'll ferment, but they don't usually. And you can see here, can you see the price? So this is for 300 grams, so like the size of a Coke can. $40, did you see that? So a lot more pricey than regular honey. So this is kind of a not completely extinct practice, fortunately, but severely declining. And recently, and this is because young people in these very rural communities, they just leave and are not interested in maintaining the traditions, and so then nobody cares for the colony; it just dies. But there's a recent push. A lot of people are trying to bring more education to the communities. And the thing is that now this is kind of like, this is going to be like the new quinoa, something that some culture used for hundreds of years, maybe more, and then it's definitely recently discovered. So if you go to actually in those places to like something like like a yoga something, like a special emphasis on like the natural and stuff, that they're gonna definitely have this kind of stuff. You can find it online. And so that, the price of this and the growing demand can be a good thing, because then people might be more inclined to actually continue the practice. You have to be careful too, because you don't want to incentivize over harvesting. That might be bad for them too. So it's a little bit delicate balance. And of course, you always have to be careful with being culturally sensitive. So for example, some bee biologists wrote a whole guide to how to do this in Mayan, like a little book, and then they took it to the communities, and they're like, we don't write that. We speak it. Nobody knows how to write it. Nobody knows how to read it. So it's a little bit of a wasted effort there. But I just show you how these guys here. This is them in their entrance. So their nests are in a cavity. And they cover it with wax and stuff, and then they make this wax tube that comes out of it. And the shape of that tube is how you tell what species there are. One way of telling. Even without the bee, you can just look at that and know. And here, what they're doing is they're all in the tube guarding it, because they're stingless, so they have lost the ability to sting, but there are no suckers. They can still definitely defend their nest. Bees have mandibles too, so they can still bite the hell out of you. And they also, some have even other kinds of mechanisms of defense. One I don't know if it's one or more than one, at least one, is able to produce a chemical from their mandibles that when they bite you, they leave blisters. So no joke. Okay, another thing that I wanted to tell you about is about buzz pollination. Okay, so most flowers have what we're familiar with more, that the anthers, so the flower has like the male part is like a little stem thing, and on top the thing was holding the pollen, that's the anther. And usually, to release, when it's ready to release the pollen, it has a slit, longitudinal slit, and that just, like all the pollen is out there. And this is the images that you always see, like of a bee on a flower that is just landing, and it's like full of pollen, or that you touch a flower and you get your full pollen right away. That's because their anthers are, they're promiscuous. They don't care like where they end up. But some flowers have these kinds of anthers, and peristidal is in pore, and these guys are very restricted on where they leave their pollen. So they don't like just let it go. They have, so here you can see this is the anther, and it has a little, can you see it? It's a little hole in the top. So these, the bee has to work hard to get it. So they have to, actually the only way to release it is by vibrations. And so a bee that can't do that will come here and not get anything. And does anybody recognize like what kind of flower this is? If you garden, you may know. If you garden for vegetables and fruit. Sarah? So it's tomato, potato, those guys? Those are the main ones. So not a lot of these guys, I told you not a lot of flowers have it. It's about 8% have this kind of pollen release. But they're very economically important ones. So potatoes, tomatoes, eggplant, cranberries, blueberries, all those guys need this special vibration to release it. And these guys, normally flowers, they bring in the bees by offering them nectar, kind of like a reward for coming to the flower. These guys don't even give them nectar. They're just pollen, and you have to work hard for it too. And the thing is that honeybees can't do this. Honeybees are not able to extract pollen from these kinds of flowers. They don't know how to buzz pollinate, to create that vibration to be able to do it. So that's why we can't really just rely on the honeybee. So if you think tomatoes, potatoes, those things are big, economically important crops, and they cannot just use the honeybee. They have to use, well, they can use, a lot of other bees can do it, but the ones that are easier to raise and to have the way that honeybees are used are the bumblebees. Let me see if this video is going to work. Okay, I want to show you anyway, so let's do this. Okay, so it's called buzz pollination or sonication. And it's just about the vibration, so you can mimic that by using a tuning fork, an E I think. And so you can see it wasn't doing anything, and then once you put the tuning fork on it, it releases all of the pollen. You can also do this with electric toothbrush. And let me show you a bee doing it. That's the same one?
Now, nectar is made specially for the purpose, and it's costly. And there are some flowers that get away without.
Where is that coming
nectar,
from?
like this
Oh, this is, it kept going. Let's do this one.
The following is a production of the University of Minnesota.
Okay, so this guy is doing it. So you see all the pollen falling there? And it's, well, you can't really see it here, but it's not beating its wings like in flight, but it is doing this with the flight muscles. And so what these guys are capable of doing is uncoupling the muscles from the actual flight. And so they're just vibrating, and then they put some part of their body onto, that's an electric toothbrush doing that. They put some part of their body, usually their mandible, they can touch any part of the flower, and then those vibrations will be transmitted to the flower, and it will release the pollen. So we always think of honeybee as the important one for crops, but we can't just rely on them. So honeybees are, they do us good. We can't hate on the honeybee, but they are, first of all, they're introduced. And we're not too concerned about their effects as an introduced species, because they've been here so long that, whatever. Some people study a little bit what they do to native species, but in general, it seems to be not a big of a deal. But for crops, though, these guys are not that effective because, for two reasons. One, they can't buzz pollinate. So any kind of crop that requires buzz pollination, which is a good number, it will not use honeybees. It will not be effective. And the other thing is that, kind of related to this, is that honeybees are generalists. So they'll go to any flower, which is good in some cases. But the problem is that sometimes flowers have special things. So this is one kind of special thing that makes it so that a generalist can't really be as effective at pollinating. So for example, the time that they're active. So squash and all their related things. So definitely pumpkins and zucchinis and melons, what else? Cucumbers, watermelons. All those guys, they have, maybe you've noticed this if you garden, the flowers open only in the morning, and then they're like me. And so that means that if you are going to pollinate that one, you better be up early in the morning. And so honeybees are not that good at that. So they, so the ones that really are effective are a kind of native bees, the squash bees. That are specially adapted. So those guys wake up super early. Actually, I've never collected one probably because of that. They wake up super early, do their thing, and then they're done. And it's super cute because some of them, the males, sleep inside the flower. So if you're up early out in your garden, you should look in your squash flowers because they can have sleeping bees inside of them. But other things that flowers can have that make it so the honeybee is not that effective could be like the size and shape of the flower. So if to get into the flower and to actually touch the anthers that have the pollen, it's a super deep flower that they have to go in and have long mouth parts, then the honeybee is not going to be the best. So for certain crops, they've seen that even if you are stalked, like almonds in California, where they're going to bloom, the trucks full of honeybees are taken there, and so they're full of honeybees. But they've measured that even when they're full of honeybees, if you have native bees, and so that's just about having a healthy environment around the crops, to be able to sustain a population of native bees, then your yield and your fruit set increases. And so they're super important. We can't just rely on the honeybee for pollination. Another cool thing that I think about bees is that some of them don't do what most of them do. Most of them are hardworking ladies. Most of them are hardworking moms, single moms, that have to do everything on their own. But these guys, same as the cuckoo birds, those guys, like the brown-headed cowbird, for example, they don't build their own nest. They wait for a female of another species to build their nest, lay their eggs there, and have that mom take care of their chick. Same thing here. So these guys don't build nests, and instead they go around looking. They're still in the flower because they have to eat nectar just for them, but they don't have to collect pollen because the pollen is for the babies. And so they go around flying. These guys usually you can see because they fly close to the ground looking for nests. And so while the hardworking single moms are out collecting nectar and pollen, these guys are waiting for them to leave so they can go in their nest, lay an egg, and usually it varies. There's some gruesome things. Some like larvae have like some really big mandibles so they can eat the other larvae and stuff. But that's what they do. They eat their food, the food that was meant for the original one, that little ball of pollen and nectar, and usually they also eat that larvae of the host, and then they develop there without having to do their own work. And actually, this is not that uncommon. It's about 15% of bee species are cuckoo bees, it's estimated. And it's a behavior that has evolved in multiple lineages, so a bunch of times. And when I showed you at the beginning that I tricked you, that I told you that there was 2 bees when it looked like it was 1 bee, that other one was this guy. So what do you think they look? They look like wasps.
Parasitized wasp nests.
I don't think so. Most of these guys are pretty specific. They're not just looking for any nest. They look for either one species or one genus. So just a few different species that they're willing to steal from.
Because they don't have to collect pollen.
Exactly. So bees, the main characteristic of something that you say this is a bee is when you look at their hair, and their hair is very, very hairy usually, and their hairs are branched. These guys have lost most of their hair. You can tell that they're bees because they have certain cells on their wings that we use to identify them. But if you want to be for sure always, you have to look around to find hair and see if it's branched, and then you know it's a bee and not a wasp. But it looked like that. Okay, and then this is another thing that I think is extra cool of bees. This guy is they're not native to the US, but now they have been documented in Florida. They're tropical species, and they have super cool interactions, coevolutionary relationships with orchids. So usually it's one species of bee with one species of orchid, or one genus and one genus. And this was something that is, for a long time, they really didn't know what was going on because it had a lot of weird things going on. So, for example, it looked like, weird thing, that the male was going to collect something from the flower. And usually the males don't collect anything. The female is the one that's collecting pollen from the flower to take to her babies. But these guys were doing obviously something. So they were on the flower, this is documented a lot, on the flower collecting something, and they're flying, they're hovering over the flower, and they would kind of like tap their legs together. And you can see their legs are weird. They have super enlarged legs, and if you were able to see the inside, it has like a spongy structure. And that's what they use to collect scents. So they're not going to the flower to collect pollen. They're going there to get the smell of the orchid. And in here, they do something. This is still not well understood exactly what happens, but they do some kind of chemical transformation in the legs of that scent and turn it into a pheromone that they think they use to mark territories and to attract females and stuff like that. So this is tropical, as I told you, and I have one of those guys if you want to see it here in my little collection box. The ones that I have are from Costa Rica, which is where I've done a little bit of research. So that's where our stingless bees are from, that are there. And this guy, and I also brought honeybees that are collected there, which are all Africanized. That's another thing that I forgot to tell you. So you may have heard the story about how that happened, that they were studying this honeybee from Africa, that they wanted to actually breed from them the characteristics that they're super hardworking. They produce lots of honey. The problem is that it's from Africa, so it wouldn't be able to live in a place that has winters. And so that's why they wanted to see if they could breed something from there into a strain that does live in winter, through winters. And they released it. There's conflicting stories of whether it was accidental or not, but in Brazil it was released in the 70s, I believe, and from then it has spread out from where it was originally released. It hasn't come to Iowa yet because of the winters, but who knows with global warming, what's going to happen. And the problem with these guys is that they're super aggressive. And so people where there's Africanized honeybees, they just don't beekeep anymore because it's too dangerous. And so that's also why the stingless bee now is more important, because a regular honeybee was easier to harvest from and to keep and everything. So they were doing that instead of the stingless bee. But now that it's not easier, that is actually benefiting the stingless bees. Okay, so what are the threats to bees? You may have heard of a lot about the honeybee being in peril, right? I'm not too concerned about the honeybee because it's never going to go extinct. Probably never going to go extinct because it's a domesticated species. It's in huge trouble. So the colony collapse, where that you heard about a few years ago, where the characteristic of that was that the bees would leave and not come back, so there was like a deserted hive. That is not really happening anymore, but they're still in trouble. So in recent years, in Iowa, for example, about 70% of hives die in the winter. They don't make it through the winter. So it's a big issue. It's a big issue for people that, especially they're relying on that for their income and honey or pollination services, whatever. But it's also something that you can solve by ordering more. I mean, they're a domesticated species, so if your hive dies, you just get another queen with more workers, and you just start over, which is not ideal. But what I'm saying is that when we're concerned about the bees, we should be more concerned about the native bees, because their role is super important too. And the thing is that we don't have a lot of studies on them. You would be surprised how little information we know about the status of bees. And I'll give you a little idea here. But the main things that are getting them are these. And it's what they thought even for the colony collapse. But the reason that we have these 70% loss every winter seems to be not one thing, but a combination of factors that are affecting them a little bit each, making them vulnerable to other things, and that's resulting in the issues that they're having now. So habitat destruction and fragmentation, and this is, obviously I've seen this, how Iowa is mostly agriculture, but when you go out to try to find study sites of non-agricultural sites, then you realize how everything is agricultural here. And the original tallgrass prairie is 0.1% of its original extent there. So 0.1, not 1, 0.1%. Like we have like almost nothing left of that. And of remnant prairie, like of things that have always been prairie, that's even less. Some efforts have been done to increase more prairies by just planting them too, so that's good. And then the other thing that is super related to why there's habitat fragmentation are the use of pesticides. And you may have heard of the neonicotinoids, huge problem now. These are chemicals that they coat seeds with. And then when they plant them, then they're in the whole plant. So years later, these are going to be annual, but they stick around. So they're going to be in all the plant. It's a systemic thing. And what sucks, though, is that it gets onto everything else. So they've looked at hives, the pollen that they have there, and they're pollen from wildflowers, but they're still full of neonicotinoids. So it transfers. And they've done lots of studies of the effect that it has on them. And initially there's like criticism, like with always when with toxicology stuff, is that the doses that they used were not realistic, that bees don't really encounter that in reality. But now they've done all kinds of study at all kinds of doses, and they have a major effect, especially the non-lethal doses. So things that are not killing them, but affecting them. They think their immune system, which makes them vulnerable to parasites, which makes them vulnerable to other things like viruses. And so there's a whole combination of things that is affecting them. And it affects the progeny, their lifespan, the sperm production in males, tons of things. And the other thing that is huge is exotic species. And so introduced species of bees, actually. I'll show you next that we have several bumblebees that are showing serious declines in their populations, and they have realized, and this is kind of recent actually, that they have been affected by parasites that were in those bumblebees they introduced from Europe. So Europe, because they're older, they've been doing research on bees for a long time, and they were the first ones in England to figure out how to raise bumblebees. And that's a huge thing for agriculture, especially for they're thinking like tomato greenhouses and stuff. They put the hives there and just have them pollinate all their tomatoes. And so, it seems like a really good idea, so they brought them here. And they spread their diseases. So that's what they think is one of the main causes now of the declines of bumblebees, which are the only ones that really have been studied to that degree. So we have no idea what effects it has on the other bees that are not bumblebees, which are actually the majority of them. They even later, they realized, maybe it wasn't such a good idea to start bringing species back and forth. But since they had the technology to do the breeding in Europe, they brought a bumblebee from here. It's called Bombus impatiens, or Eastern bumblebee. You may have heard of it. It's definitely what you've seen. It's the most common bumblebee in here. So they took it to Europe, and they learned how to breed it there. And then they brought it back. So over there, it caught all the diseases of European bees, brought them back, native species, but loaded with parasites not from here. And so what happens is that when you have a parasite that has been around for a long time, you have a coevolution. So it kind of ends up being like, okay, we live together. Okay, you affect me, but I already learned how to fight it back, so we can live together as your host and parasite. But when you have a new parasite or disease or whatever come in, that's when you can, in some cases, depending on the genetic makeup of the population, they cannot have sometimes any defenses or very bad defenses against it, so it can disseminate the population. And so that's what we think is happening with bumblebees now, that some just genetically are able to deal with those, like the Bombus impatiens, the eastern bumblebee, that guy is doing great. But other ones haven't been able to deal with that. And so they're in trouble. For example, this guy, have you heard of this guy? He's now in the endangered, listed as endangered. There's a really cute little short that somebody made about this that I would recommend to watch. So this guy used to be all in Eastern Europe, like 28 states, super common, widespread. And now it has lost 90% of its range. So it's found in 10% of where it used to be.
Is this an American bee?
No, that's my next one. It's called the rusty-patched Bombus. Oh, no, this guy is native. Native to us and in trouble, probably because of the introduced ones. And then the next one, this guy is not in the endangered list, but it should be. Well, there's lots of, it should be. So this guy is one that you may see here, and I have one here, I brought it for you to see too. It used to be here. Now you'll see it occasionally, and you should get really excited when you see it. And you can see here, original range in the dotted line, current range. And the thing is that we don't know we haven't been able to study systematically these populations. So the way that they know this thing is in trouble is by going into collections that, like universities and museums that have been collecting for many years, sometimes 100 or more years. And so they've gone through all those collections and seen where it was found through time and where it's found now, and they've seen this. And so they've done that with, bumblebees are, fuzzy. They're like the teddy bears of the insects, I think. So they have a lot of attention on them, and they're bigger, So when we study them, we see the issues that are happening. And we have all these 20,000 other species that a lot of them don't get any attention. Some haven't even been described as species yet. So we have an enormous lack of information to really know what's going on with the bees. What can you do to help? You can actually do a lot. I think the main thing you can do is to not be so obsessed with your lawn. So if you're able to plant plants that provide the food, the nectar, and the pollen. So here are examples of things, and these are also pretty flowers to have. And lots of these have native varieties. So whatever you plant is awesome. The bees will love it. Whatever plant the bees like, bee pollinated plant. But if you can plant native things, that's even better. And if you can plant native things that are from here, so if you can go out to a prairie and collect seeds, for example, locally, and maintain those, that's even better. But whatever plants that you provide, even if you have your herbs for your cooking, that's awesome. They love mints. And mints, there's a lot of native species of mints. And that's something that you make your garden smell nice. It has benefits. And what I'm saying about not being obsessed with your lawn is weeds are good for bees. So dandelions, they're not the best food for bees. They have a really hard, the pollen has a really hard exterior that the larvae have a little trouble getting into. It's like eating nuts without a nutcracker, I guess. But in the spring, these are the first things that come out. So you want to keep them around because even though they're not the ideal food, sometimes they're the only food they have. So if you keep them in your garden, first of all, if you're applying chemicals to get rid of them, and then you're not, that's even better, because that's the other thing, that we don't want to give them more chemicals. They're already so exposed with agriculture, so if you can withhold a little bit, that would be awesome. Now, this is sometimes hard, so you can decide to not put things in your garden, but when you buy flowers too, or plants in general, lots of them come with even neonics, so lots of pesticides in them. So if you can find a place where there's organic things, that's even better. And the same in general with organic food. That means that they're not putting those pesticides that are bad for the bees. And you can also provide places for them to nest. So most of them are ground nesters, like 70% of them. And so if you have just ground that is not lawn, not mulch, just a little bit, it doesn't have to be all of it, just like little things here and there, they'll love that. And there's also bees that have, that use pre-existing cavities. And so people do little hotels for them. So if you're into crafts, you can make something like this. So they make them with different sizes, so different species different sizes. So you can cover all of them. You can give them a good place to live. And I'll take questions, and hopefully this wasn't too boring. You weren't asleep like these little males. And males don't have nests, so they sleep out in the wild. And several of them can hold on to, with their mandibles, to a blade of grass or something. Some are in flowers. But hopefully this didn't put you to sleep. Any questions? And I believe they want you to go up there because they're recording this. So if your question is in the mic, it will go into the recording. But if that intimidates you, I can just repeat it.
I'm not clear on Africanized. Could you summarize again? Because I think I heard you say it's a variety of bee developed in South America, released in Brazil, and then that particular that trait has spread?
Yes.
Would you please
Yeah.
tell us more about that?
yeah, so the honeybee has varieties, so subspecies in this case they're called, and so we have the one that we use here is from Europe. It's Italian actually, and there's another one that just evolved in Africa naturally from Africa, and they're super hard workers, and so they wanted to get that trait of being hard worker into our European one. And so they brought it from Africa to study in Brazil, and from there it was released, and then it interbred with the European. And so all the ones, and it's a super, they tried to do a lot of things to prevent this. They wanted to have, so that have more queens of the regular European, but they realized that when there was an Africanized one, it was faster, so it would come up earlier, and emerge earlier, and then go kill all the other queens. They usually do that. They would kill all the other queens, so they were the only ones left. So they're very aggressive in that sense, but also that they sting a lot. So if you go near their hive, you're likely to get stung to death in some cases, actually. Does that answer? Any other?
And that population continues to spread, and it's only held in check by cold weather.
Exactly. So it's still in North America, but up to Texas, I think it is now.
Thank you.
Anything else?
Yeah, I was just curious about, have we seen some decline of plants related to the collapse of the range of bees?
I don't think yet, but that is something that is predicted to happen. And especially thinking about global warming. So it hasn't been tested yet. I haven't found evidence that global warming is affecting bees, but the prediction is that it will. And one thing is that it changes ranges. So they used to be able to live all here, but now they move. And the other thing is phenology, so they can come up early. So if they're usually coming up in May, because in May temperatures are something, but those temperatures are not coming up earlier, then they might come out. There might be a mismatch between when the plants need to be pollinated and when the bees are actually available. So things to watch out in the future, actually.
So we have quite a few parks, both local and county parks, that have these prairie restoration sections in them. Mm-hmm. So I'm always kind of curious just how effective they are. I mean, do you have any data as to, does it matter how well they're done, or whether they introduce the fire suppression things, or do we have any idea of how effective these are, even if they're small plots?
They're always going to be effective. Anything that you can do is going to help. Now, how effective? Some people are studying. Actually, I have a project where I'm comparing remnant with planted prairies. But you would expect that the more diverse prairie. So there's certain species of plants, for example, that when you plant a prairie, they either don't come up. You plant them and they'll come up, or they come up years into the in planting. And so you would expect something similar happen to bees. So some are hardy and they'll appear anyway, and some are specialist relationships that will only appear there when you have a well-established prairie. But I can give you more information next year, I think. Anything else?
Can you harvest honey from Africanized honeybees?
If you want to die. Yeah, so technically you can. They make their hives in exactly the same way, so they work the same, but they just get a lot madder when you do it. So that's why people don't do it as much, because it's just so dangerous. They'll be mad at you for a long time and try really hard to get into the suit and potentially kill you. So what they do now, for example, Costa Rica, where I go more, people don't keep them, and feral ones, they try to kill get rid of them, burn them or something, because anywhere around there, then it's super dangerous for people and animals.
Even smoke, traditionally they use smoke, and that calms bees, and that doesn't work.
I mean, it calms them, but not that much. That's it. Well, thank you so much for coming.